Okay. Um, so my goal here is to try to get through 7 as quick as we can, so that if we have some time left, people can ask me questions from 1-6 if they have any. Yeah. It's Cal Naughton Jr.
I've never seen it. Is that Talladega Nights?
Yeah,
I've never seen a baseball jersey.
that's because we made them.
Oh, really? That's cool.
The group of us that goes fishing every year made jerseys for fishing. So we're all different character from the movie.
Nice.
1-7 is probably easy. I say probably because there are different methods of solving it. I'm going to show you the method I think is the easiest. But again, there's different ways of doing a lot of these, and so if you don't like the method I show you, I can show you the other method that is used, / the method that is in the pre-written notes. So usually when I post the notes for you guys, I post the answer key to the packet as well. And the person that filled those out does a different method than I do. But I feel like this should be relatively easy because we've already kind of done it. We've already talked about answers that are infinity. So like if a graph goes straight up or down, those would have answers of infinity, negative infinity. And then limits at infinity is when you put infinity in place of x. So like it's the limit as x approaches infinity. So we've essentially actually done all of them already. This is us officially going over it now. This must be all the Chromebook covers. Well, they're safe now. It's got a $100 cover for a Chromebook that costs $100. I have no idea, but I can't imagine there are a ton more of them in the Chromebooks because those aren't very expensive.
On the side of my Chromebook. That's the only thing
Cool, Canadian hockey jersey. Let's go with you first. I like that one. So we've got the picture up there. Could you tell us or remind us how we would figure out there's a vertical asymptote at 4 and how we would figure out that there is a hole at 2?
You factor out your function and see where like your factors can't stop.
Okay, so the factor that did cancel, what did that create?
That would have been your hole.
Perfect. So x minus 2 would have canceled out. And that's why we have a hole at x equals 2. And since we have a vertical asymptote at 4, do you remember what factor would have been on the denominator?
-4.
X minus 4. But you're right. So that's kind of how this works. I didn't feel like we needed to take the time to actually factor this. So from the picture, we generally can get a lot of these answers anyway. Why don't you call the next person?
Like a desk number?
Okay. Person or desk number.
Okay, how about 13?
I don't know where 13 is. Oh. Was that on accident?
That actually was nice.
Okay. I was hoping you could help me answer one of these 4. I'll let you pick. And we can just use the graph.
Could I do -1 to the left?
-1 from the, +1 from the left? Okay, good, because -1 from the left wouldn't work well.
What if you like 2.5?
Yeah. I mean, that's just like our guess.
Yeah.
Otherwise, how could we find the exact answer? Just put 1 in place of x.
Yeah.
So we have 1 from the left and 1 from the right. And to be honest, we don't need to do those from the left and right because 1 is on a continuous part of this function. So if it's on a continuous part of the function, you can just put 1 in place of x and get an answer. The only numbers that we can't put in place of x are 2 and 4. So 1, what would we get? Somebody already do it? Is it 2.5 or is it close? So -2 minus 2 is -4 plus 12, 8. 1 minus 6, -5 plus 8, 3. I already forgot what the top was. 8? 8 divided by 3? So I guess it's 2 2/3, 8/3. Okay, so good though, very good. You get to choose the next person that actually has to do more work.
26.
Nope, I mean, there's 2 other ones to pick from here. And we can just go by the picture, you don't have to go by the equations, because we have a picture.
4 from the left
Okay, so 4 minus,
and 4 from the right.
okay, what's the answer for 4 minus? Or do you want me to kind of point out to you where that is?
Undefined.
Undefined? So 4 minus would be right here, because on the left-hand side of 4, the graph is going that way.
Infinity.
So it would be infinity slash does not exist. We're just gonna write infinity from now on though. Like, I'm okay if you guys don't write comma d in. And then write,
Any. Wait. Oh, no, oh, negative then.
the best is that you're squinting at the whiteboard, but you have the thing printed on a piece of paper in front of you. So negative infinity are correct. Okay, we're gonna pretend you would have made a discovery even though we already knew what it was. So the discovery here is that factors that cancel create a whole, factors that remain on the denominator are vertical asymptotes. Nice discovery. So, oh, there's an F and a G. I was gonna say, why is there both there? Wait, was there a G up above? Oh, yeah. Well, no wonder why they asked 1. That didn't make any sense to me why they were asking 1. Why didn't you guys tell me that when you were looking at the dual-sided piece of paper?
I didn't notice.
No, I definitely didn't either, so I'm gonna pretend you guys were definitely smarter than me. Okay, well, what I would like to do, oh, that is G. I just want to talk about the infinity ones. Now, we obviously have a picture to go from. We're not gonna use that. So we're gonna start talking about how you would calculate the answer from infinity. Now, I kind of started talking about this a couple days ago. Is that you compare infinity to other things. So if I remember right, I think we had a power that was infinity plus 1. And what I tried to tell you guys was infinity is such a big number on its own that adding 1 statistically does nothing. Like, if you wanted to try to calculate the change, what did you guys call it in L2? Percent change? I think that's what you referred to it as? Percent error? Whatever. So, infinity plus 1 is so statistically no different than infinity that they are the same thing. So whenever we are working with infinity, we ignore everything that is a lower power or lower thing than it. So infinity plus 1, we would treat as just infinity. Here's the one that usually kind of confuses people though. I know some people are gonna wanna say this is 0. Because infinity squared is infinity, right? Like, it's already supposed to be the biggest number possible, so if you square it, wouldn't it just be still the biggest number possible? But on this one, minus infinity is so much smaller than infinity squared that it's worthless. It's kind of like the plus 1 up there. Plus 1 is so much smaller than infinity that it doesn't change anything. So guaranteed what you've never thought of is what infinity squared means. I mean, maybe you have, maybe you've been super bored and just thought of these things. What does 2 infinity mean? Infinity plus infinity, you're putting 2 different infinities together. So infinity squared means an infinite number of infinities. Like you're adding infinity an infinity number of times. So infinity squared is like, most of you, the square just doesn't feel like it should be that much bigger. But since this number is crazy big to begin with, infinity squared is a ridiculously big number.
What about infinity cubed?
That would be an infinite number of infinities.
How's that any bigger than infinity squared then? Since infinity is everything.
Because there's 3 infinities.
How is an infinite number of infinities bigger than an infinity?
Ooh.
I mean, like, you're not wrong, but you're not right. So they kind of start calling that theoretical math.
Question.
Go for it.
If there's 2 infinity minus 1 infinity, would that be infinity or would that be 2 infinity because 2 infinity is marginally larger than infinity?
I was gonna say 1 infinity, but
Because you're making the argument that infinity squared is so much larger than infinity that minus infinity would be irrelevant.
oh,
But
got
2
you.
infinity is larger than 1 infinity.
But not by a degree that would make it irrelevant.
So where's that line?
It's not a bad question. I mean, that's a good question. I don't determine it. I'm not gonna consider myself smart enough to
What if
know.
it's like a million infinity minus 1 infinity? Would that be 999 infinity?
I would say so, because infinity is supposed to be so big beyond any number you can think of that doesn't count.
Infinity root.
So if it's a number you can recite or a number you know of,
Infinite something.
that's not big enough. Yeah, I mean, it's,
How many infinities?
yeah. So I brought that up because when we plug infinity here, if I plug infinity in, I've got infinity squared on the top minus 2 times infinity plus 5. Now, for purposes of us trying to find the answer, we're going to cross off anything that is lower powered.
Wait, I have a question.
Yeah,
If you have infinity squared divided by infinity, would that be infinity?
Yes.
Because it's squared.
that's what we're doing.
Okay.
What are you doing? Is today a rough day or what?
Yeah, I'm just tired.
Oh, okay. We're gonna cross off, the minus 2, because that's a regular number. I mean, I know infinity's a regular number too. We treat that like an x almost. Okay? So now that we have infinity squared over 2 infinity, they kind of work like variables in that you can cancel one of them. Now, the divided by 2 would be remaining, but the divided by 2 doesn't change it out of infinity. It's like a plus 5. It's a lower degree infinity, than a regular infinity.
So how do you say that?
But there's only one half of it. Let's just, I take your infinity, I split it in
That's a
two.
lesser infinity than infinity.
You have less than divide by one.
So, I know.
You told me I could understand.
Wait, who answered next? Who's answering next? Oh, I know, I see your question, hold on. What?
36.
Oh, Cullen.
Well, that felt very targeted. However, he is 17. There is no 36.
Alright, so.
Oh, okay. What are the possible answers that we can have when we try to say limit at infinity? There are 3 possible answers.
When you say the limit is at infinity?
Yep, so limit at infinity means we are trying to say, what's the answer all the way to the right? There are only 3 possible answers.
Is infinity one of them?
Goes up, that would be infinity.
Negative infinity?
Negative infinity goes down, so that's the second possible answer. Third,
Zero?
it flattens out and it could be a normal number. So yes, 0 is one of the normal numbers. So out of the 3 possibilities, what we're trying to do is figure out if the answer is positive infinity, negative infinity, or if it flattens out to a regular number. Now, if we've got all these powers and stuff, what's the only way we're going to flatten out and get a regular number answer? Do you remember this from pre-calc? How did you get a horizontal asymptote to be a number in pre-calc? Because in pre-calc, you guys only looked at the highest power, correct?
Yeah.
And you looked at the coefficients on the highest power. How do you not remember this?
I remember.
Oh, yes, you only looked at the highest power, and then you just looked at the numbers on that.
Wait, so infinity minus 1.
The reason that you only look at the highest power is because all the lower degrees are insignificant in terms of figuring out what the answer should be. Like this, which I realize the infinity breaks the brain. It should. It's supposed to be bigger than we can think of.
Who created that concept?
Mm.
That's
I'm not that big of vast knowledge. I wish I was, but I'm not.
Isn't it not?
No, most people can't even fathom what a million is. Yeah, so infinity is like so far out there we can't figure it out.
It's just infinite. It's not a number.
I don't like that guy.
In 1659, John Wallace created
John Wallace?
John Wallace.
Are you trying to curse John Wallace right now?
I didn't say anything.
Oh,
I'm trying to curse.
you're cursing him.
I'm just letting y'all know.
Think of it like.
Understandable. I'm sorry, I did forget to ask you. Because it's a lower degree. Okay,
I think it's like infinite.
now,
Every time you say something.
we're gonna focus on next page. A on next page. Oh, not A. Find infinity, is that below it? Here we go. I don't know what number this is. This is 59, page 59. At the bottom. If we are going to be plugging infinity in, what's the first thing we should do according to the crazy math from page 1?
Yes,
Get rid of the normal numbers?
Get rid of anything lower than the highest power. 59.
Thank you.
I mean, it'll.
Okay, so if I'm looking at limit at infinity of 3x squared minus 4 over x squared plus 1, the first thing I'm going to do is 100% ignore minus 4 plus 1. They are lower
Wait, where?
Bottom page 59.
It's infinity.
Bottom page 59. So when you are dealing with infinity, you actually revert back to the pre-calc rules that you learned, because those rules were come up with by limits at infinity.
You ignore those so long as you're not graphing.
So
It's like
is
if
the
you're
answer
graphing, that affects
three?
envelopes, right?
It only affects the interior, not the not the horizontal aspect.
Yeah.
So is the answer three?
Yeah.
Ooh.
So if we plug in infinity, you treat them like x's, then you get 3.
I like infinity.
It works very good in terms of quickness.
One over infinity.
Okay?
We just confused the negative infinity power.
They're so much smaller than that they don't change. Okay, on D, they are different powers top and bottom. So what we do when we are plugging, I want to absolutely clarify, this only works when we plug in infinity. You plug in a normal number, you can't just randomly get rid of stuff. So if we're plugging in infinity, top and bottom separately get rid of lower degrees. So I know the x on the top is a lower degree than the squared, but you do top and bottom separate. Okay, so now negative infinity, I would have 5 times negative infinity over negative infinity squared.
Can we get rid of the 5?
Well, you have to deal with the positives and negatives. You have to deal with positives and negatives. So this would be negative 5 on the top. On the bottom, negative infinity squared would turn positive. Oh, sorry, I forgot to write infinity. The bottom, the negative infinity would turn positive, so you would only have infinity squared. So you kind of simplify it first before we cancel them out like variables.
So the negative infinity.
So would it be negative 1 over infinity?
You have negative 5 over infinity, no power. And in this case, this I believe we did earlier when we were,
That's the same thing as times 0.2.
does anybody know what this answer should be?
Negative infinity.
0. The top,
I thought I had it.
what would 1 over 100 be if you divided it on the calculator? It would be 0.01. 1 over 1,000 on the calculator would be 0.001. 1 over a million, 0.00001.
Actually getting to 0, it's just.
The bigger the bottom number is, the closer the answer is to 0. And limit is us trying to figure out what the answer would be. So it doesn't matter that it's negative because the answer is just about 0. We could say negative 0, but that's not a thing. So 0.
Say that was negative 5 over negative infinity, it should be 0.
If it was negative 5 over negative infinity, the negatives would cancel, but the answer would still be 0.
What if it was 5 over negative infinity?
Still
Still 0?
0.
Okay.
Because infinity's in the denominator.
Positive 0 and negative 0 are not a thing, so we don't keep track of it.
So if you were to like try to find like the square root, or like,
We're getting there. That's actually the next one. You're right though. You're right. Square root acts weird. Yeah. Go ahead. Okay.
Thank you.
Oh, it's still good. It's still adjusted. It's still good.
Wait, can we do basic?
The only reason this one didn't work is because it depends on the denominator.
There we go. Finally. It says challenge because it's very difficult if you do it the way she shows you to do it. It's the very last page of notes, I believe. 62.
I don't like this.
Okay. First step, if we're going to be plugging in infinity, I know they're down there. But if we're the limit is written here.
Why does it go up? Sorry.
Oh, yeah, you're right.
Why does it do that?
I can answer that question afterwards.
Because it has a minus.
Okay? First thing we do is the same as before, cross off things that are lower powered. So -3 and +4 are the only items that are lower powered. Now, you can leave it as square root of x squared if you would like. What you cannot do is make it x. So we haven't run into this much at all before. Do you guys remember what square root of x squared turns into? It's not x. Kind of. We used it for plus and minus, but it's not actually plus and minus. It's absolute value of x.
Oh, yeah.
So the plus and minus is if you're trying to solve for what x would be. So this would be 3x over absolute value of x.
What?
No matter what number you put in place of x, the answer would be positive.
Yeah, because it's squared.
Yeah, so it's actually the absolute value of x. We've just never needed to write it that way before. So now if I plug in the infinities, it's not difficult, but this is the difficult step, is knowing that that's square root of absolute value of x. So,
is it not
Negative
infinity?
no, the x's cancel.
You're right.
So if I plug in negative infinity, that would mean me saying 3 times negative infinity over absolute value of negative infinity, which is positive infinity. So the negative stays with the 3, and my answer is -3.
I like this.
But the positive infinity doesn't get affected in any way.
Infinities cancel
You're gonna
negative
unfinish
three.
your-
Positive
That's
3.
negative infinity. Yeah. And they cancel.
Okay, now we'll go back to your question.
Also, it's a negative.
Why can the graph go below the horizontal asymptote? That's assuming what you're asking.
Yeah.
So you guys were probably semi-taught that a horizontal asymptote works the same as a vertical. My guess is every question you had, you were just basically told to hug the asymptote because it can't cross it.
Yeah.
Okay, that's actually only true for vertical. Horizontal asymptotes aren't an actual thing. Limits, horizontal asymptotes are an easier idea that they teach you ahead of time instead of teaching you limit at infinity or limit at negative infinity. So horizontal asymptotes don't actually affect the inside of a graph. Horizontal asymptotes only work on the outsides. The inside of the graph can cross it all at once. Now, you don't run into that often, but it doesn't matter on the inside.
How can you tell what's on
As
the
long as
inside
it
and the
ends up
outside?
Uh,
Like when it crosses over?
well, we actually get there in unit 3. I was gonna tell you to look for the critical points, but you don't know what ours are. All right.
Outside, you kind of just move.
That's okay, we do get to that.
As it approaches infinity, that's moving by outside.
Okay, very quickly, I will show you the method the book uses, because some people absolutely think that makes way more sense, and I'm fine with that. I don't take it personal that people don't like my methods. Okay, if you are doing an infinite limit, the method the book gives you, I shouldn't even call it the book, whatever we want to call it, packet. You divide by the highest power.
I know, I never knew.
Highest power in this whole thing is squared. You divide every term by the highest power in the whole rational expression. So this would turn into 2 minus 10 over x. If you divide by x squared, cancels x squared, cancels x. Why can't you guys do the division like this in your head yet? Come on. This is supposed to be something you guys can do easy.
What's
X squared divided by x squared is 1. 8x divided by x squared, a single x cancels, you'd have 8 over x. This is supposed to be what you guys excel at, is algebra. 15 divided by x squared. It's 15 divided by x squared, nothing cancels. Now, if I put infinity in place of x, 0, 0, 0, 2 over 1.
So, you know, that doesn't even matter.
Oh, okay, how would
So
this
now-
work the other way?
Essentially, they're the same idea. Because if you're on the first method I showed you, you would cross off 10x, 8x, 15.
Oh.
So they are the same idea, but for some people, this just clicks 100 times better.
Kind of just seems like extra stuff.
I don't like it because it's a lot of extra work. I can do these in my head rather than writing them up.
So you see the square, it doesn't matter. Anything that's not square,
Correct.
doesn't matter anymore.
I see these two, they have the same power. It's 2 over 1.
Yes.
Most of these, you should be able to find the answer by looking at it.
Yeah.
But if you're not a person that can, this is a method that works well.
I work hard. I like the other one.
Can you do B?
B, sure.
So this
Now, are you asking me to do B with the packet method?
No.
Oh, just to do it.
Do it. Do both. I mean, yeah, do it.
All right, but I only have a couple minutes.
1 minute.
Cross off 3, 4x, and 5. I have x over x squared. When I plug in an infinity, 1 would cancel on each, and I'd have 1 over infinity, which is 0. Negative infinity would work slightly different, but have the same end result. This would turn positive, but again, it would have the same result because you cancel an infinity from both, and you would have negative 1 over infinity, which is negative 0.
Is that if you did negative, oh, let's suppose
Negative 0.
It's 0.
It's a negative 1, I guess, 'cause you're like, oh,
You can do negative 0 for your brain to make it work, knowing that
No,
negative 0 and
negative
positive 0 are
You
still
can't
0.
have a negative because it's always 0.
Okay, book method. Divide everything by x squared. X divided by x squared would be 1 over x. 3 over x squared. 1 plus 4 over x plus 5 over x squared. 0, 0, 0, 0.
Let's do it.
Now, the reason this method I dislike is because when you get to the square root of x squared 1, you're supposed to divide everything by the square root of 1 over x squared, which is strange.
How do you
I mean, there's different, say it again? Oh, did somebody ask something?
yeah, what did you say?
Can you say it again?
Yep. The very last question that we tried, this one. You're supposed to divide everything by the square root of x squared.
So is it just the absolute value?
Yes. It just feels like it makes it more complicated because you have to figure out absolute value, positive, negative. It's not really terribly different, it's just a different method.
Are you one for
Okay, that's actually the whole section. The first part of the section we'd already done together. That was vertical asymptotes and
As long as you did that. Yeah, put it out.
plugging in to the left and to the right by choosing a number very close.